3 years ago, I was visiting a mechanic contact in Osaka who runs a small fleet maintenance operation near the city's industrial port. He serviced taxis, delivery vans, panel trucks, and the occasional government vehicle. I had gone there to look at a transmission issue one of his customers brought in. But what stopped me cold was not the transmission. It was a white taxi sitting in the corner of the bay with nearly 480,000 kilometers on the odometer. I walked around it slowly. No smoke, no visible leaks, idle so smooth it barely registered. I asked my contact when the injectors were last replaced. He looked at me like I had asked when they last replaced the steering wheel. He said they had never been replaced. Not once. Then he said something that completely reframed how I thought about fuel and engine longevity. He said the real question is not how long parts last. The real question is whether you ever gave them a reason to fail in the first place. That conversation changed everything I thought I knew about fuel systems. And today, I am going to tell you exactly what Japan has figured out that the rest of the world, and especially the people selling you fuel by the gallon, would very much prefer you never learn. Because here is the uncomfortable truth. The way most drivers in Western countries think about fuel is completely backwards. We think of fuel as a commodity. You put it in, it burns, you put more in, the car runs. That is the entire mental model most people carry with them, and it is exactly what keeps them spending more than they should, replacing parts earlier than they should, and walking into shops with problems that should never have existed. Japan does not think about fuel that way. In Japan, and specifically in the engineering culture built around companies like Toyota, Honda, and Mazda, fuel is not just energy. Fuel is chemistry that enters a precision instrument, and precision instruments require precise habits. The moment you start seeing it that way, everything changes. But before I explain what Japan actually discovered, you need to understand what is happening inside your engine right now, every single day, without you ever knowing about it. Every time you shut your engine off, something quiet and destructive begins. Injectors, those microscopically engineered nozzles that spray fuel into the combustion chamber in a perfectly calibrated mist, do not immediately cool down. They sit in residual heat. The fuel that remains on the injector tip does not just evaporate cleanly. The lighter molecules do evaporate, but the heavier hydrocarbons, the waxy, sticky compounds that exist in every gallon of commercial gasoline or diesel, stay behind. In that heat, they bake. One shutdown does not matter. 10 shutdowns do not matter. Over hundreds of cold starts and thousands of hot shutdowns, the residue builds. First it is a film. Then it is a soft varnish. Then, given enough time and enough heat cycles, it becomes carbon. Hard, stubborn, and sitting directly in the spray holes of the most precision-engineered part in your fuel delivery system. Now here is where your engine starts lying to you. When that spray pattern degrades, even slightly, combustion becomes less complete. The fuel does not atomize correctly. Bigger droplets enter the combustion chamber instead of a fine mist. They do not burn fully. The engine control unit, the ECU, reads the oxygen sensor downstream and sees excess oxygen. Its programming has one response to that reading: add more fuel. So it does. Quietly, constantly, invisibly. Your engine keeps running smoothly because the computer is covering for a problem you cannot feel or hear. Your throttle response feels roughly the same. Your idle sounds fine. But your fuel economy is bleeding away, 20%, 30%, sometimes more. All while the car behaves perfectly normally on the road. This is the trap. This is exactly what Japan solved. Not with expensive technology, not with a miracle additive that costs $40 a bottle, but with a maintenance discipline so straightforward it almost sounds too simple to believe. Here is what the research actually shows. Japan has been the global leader in hydrogen technology development for decades. But the Japanese relationship with hydrogen did not begin with the headline-grabbing fuel cell vehicles. It began with a much quieter understanding of combustion chemistry. Japanese engineers, particularly those at Toyota working on what would eventually become the Mirai fuel cell platform, spent years studying how hydrogen interacts with combustion. The findings were remarkable. Hydrogen has a flame speed approximately 8 times faster than gasoline. It burns at the molecular level more completely than any hydrocarbon fuel. When trace amounts of hydrogen are present during combustion, they act as a combustion catalyst. They ignite faster, they burn hotter locally, and they pull the surrounding gasoline droplets into the combustion reaction more completely. What that means in plain language is this: a small amount of hydrogen present during combustion forces the gasoline that is already in your engine to burn more efficiently. Not because you added more fuel, because you changed the chemistry of how the existing fuel burns. Toyota has over 5,600 patents related to hydrogen technology. The Japanese government has committed the equivalent of over $98 billion to hydrogen infrastructure development over the next 15 years. Japan's basic hydrogen strategy, formulated in 2017, made Japan the first nation on Earth to adopt a formal national hydrogen framework. This is not fringe science. This is the largest coordinated engineering and infrastructure investment in clean energy that any single nation has ever made. And at the center of all of it is a fundamental truth about combustion that the petroleum industry has known about and quietly worked to suppress for decades. Because here is the problem. If your engine burns fuel more efficiently, you use less of it, and every gallon you do not buy is $1 that does not reach the oil company. The math is simple, and the motive is obvious. But let me be very precise here, because this is where some people get confused and where unscrupulous marketers have tried to exploit a real scientific principle to sell products that do not work. I am not talking about bolt-on hydrogen kits that claim to split water using your alternator and inject the results into your intake. Those devices have been tested extensively, and the physics do not work in their favor. The alternator has to work harder to run them, and the energy cost of producing hydrogen through electrolysis exceeds any combustion benefit. Consumer tests have repeatedly shown no meaningful fuel economy gain from those kits. I want to be completely clear about that. That is not the Japanese secret. The real secret is something far more elegant, far more proven, and far more directly connected to that taxi with 480,000 kilometers on the odometer. It comes down to 2 things: engine oil viscosity and combustion chemistry. Let me take them one at a time. The Japanese Automotive Standards Organization, known as JASO, is the equivalent of the American Petroleum Institute, but specifically engineered for Japanese vehicle requirements. Over the last decade, JASO has developed 2 landmark engine oil specifications, GLV-1 and GLV-2, that represent a fundamentally different approach to lubrication than anything the major Western oil standards require. The core principle behind both specifications is what engineers call flat viscosity. Traditional multi-grade oils thin out significantly at operating temperature, which means the protective film between metal surfaces gets thinner exactly when the engine is working hardest. JASO GLV-2 uses advanced viscosity modifiers and ultra-high performance base oils to maintain a much more stable viscosity across the entire temperature range the engine experiences, from a cold start at 0 degrees Celsius to full operating temperature on a highway. The practical effect of this is enormous. Less internal friction at operating temperature means the engine converts more of the energy in your fuel into forward motion instead of heat lost to metal-on-metal resistance. Toyota's own testing showed measurable fuel economy improvements when engines running JASOGLV 2 specification oil were compared to standard multi-grade oils of even the same nominal viscosity grade. Less friction means more efficient combustion energy transfer. This is not marketing language. This is thermodynamics. But the oil story is only half of it. The combustion chemistry side is the piece that truly explains that 480,000-kilometer taxi, and it connects directly back to what Japanese mechanics discovered through decades of maintaining high-mileage fleet vehicles. The principle is this: the fuel system must never be allowed to get dirty in the first place. Not cleaned reactively, never dirty. There is a specific class of fuel detergent chemistry called polyetheramine, PEA. Unlike the generic detergent additives blended into standard commercial gasoline, which do a reasonable but incomplete job of preventing deposits, high-concentration PEA chemistry survives combustion temperatures long enough to reach injector tips, intake valves, and combustion chamber surfaces where deposits form. It does not blast them loose. It does not scrub them mechanically. Instead, it softens the varnish layer continuously, allowing deposits to dissolve into the fuel and burn off harmlessly with each heat cycle. The Japanese taxi and fleet mechanics do not use PEA-based treatments as a repair. They use them as a ritual. Small correct concentrations, introduced every 5,000 to 7,000 kilometers, into a clean system that is never allowed to accumulate enough deposit buildup for it to matter. The specific recommendation is a quality PEA-based fuel system cleaner from a reputable brand, Chevron Techron STP Ultra 5-in-1, or Liquimoli Jectron, being among the most well-documented performers, used at the manufacturer's specified dose in a fresh tank of fuel, driven normally. Not doubled, not mixed with anything else, not used every other week hoping for faster results. Just consistent, patient, chemically correct maintenance. When injectors spray a perfect atomized mist, combustion is complete. When combustion is complete, the engine control unit's fuel trims stay close to zero. When fuel trims stay near zero, the engine is not compensating for anything. It is not adding extra fuel to cover for poor atomization. It is not retarding ignition timing to prevent knock caused by unburned fuel residue in the combustion chamber. It is running the way the engineers designed it to run: clean, precise, and efficient. This is why the exhaust on that Osaka taxi smelled correct. No richness, no unburned hydrocarbon smell. Just clean combustion products exiting a system that had never been allowed to accumulate the kind of deposits most drivers accept as inevitable. And this brings us to the part Big Oil does not want discussed at all. Japan invested over $98 billion in hydrogen infrastructure, not merely as an environmental commitment. Japan is a resource-poor island nation that imports virtually all of its fossil fuels. The Japanese engineers who developed the Mirai fuel cell platform, which produces electricity from hydrogen with water as its only exhaust product, did so with a specific understanding that dependence on oil is a structural vulnerability, and that the chemistry of hydrogen combustion represents a fundamentally superior energy conversion pathway. The Toyota Mirai achieves a fuel efficiency of over 66 miles per gallon equivalent. Hydrogen combustion engines being developed alongside fuel cell technology, including direct burn hydrogen engines. Toyota has been racing at events like the Fuji 24-hour endurance race, achieve thermal efficiencies of around 44% compared to roughly 25 to 30% for a typical gasoline engine. Those numbers terrify the petroleum industry. Not because hydrogen vehicles are everywhere right now, they are not. The infrastructure challenges are real. And the legal battles over failed infrastructure promises in California are a genuine cautionary story about what happens when technology runs ahead of the systems needed to support it. But the chemistry is not in dispute. Hydrogen is the most energy-dense fuel by mass that exists. It produces water when burned. It has 8 times the flame speed of gasoline, and Japan has known this for decades while building the intellectual foundation, the patents, the standards, and the engineering culture to eventually make that chemistry work at scale. What does that mean for you today, driving a conventional gasoline engine and filling up at the same pump you have used for years? It means that the Japanese fuel philosophy is not about waiting for hydrogen infrastructure. It is about understanding combustion chemistry well enough to extract maximum efficiency from the fuel you are already burning. It means using the correct oil specification for your engine, which in modern vehicles is typically a 0W16 or 0W20 full synthetic with friction modifier chemistry that your owner's manual specifies, but most quick lube shops default away from because cheaper conventional oil has better margins. It means using a quality fuel system cleaner on a maintenance schedule, not an emergency schedule. It means understanding that every dollar you have spent on fuel since you started driving has been spent with an engine that may have been operating at 70 or 75% of its designed combustion efficiency, simply because nobody told you that clean injectors and the right oil viscosity make a measurable, real-world difference. I have changed how I think about the vehicles in my care since that conversation in Osaka. I check what oil is going in, not just what weight is on the label. I use PEA chemistry on a schedule. I have watched fuel trims stabilize. I have watched cold start idle settle faster. I have watched the kind of consistent, predictable engine behavior that high-mileage Japanese commercial vehicles take for granted become normal in engines that had drifted away from it. And here is the part that should make you genuinely angry. None of this is a secret in Japan. It is the default. It is what mechanics recommend, what fleet operators require, and what engineers design around. It is normal. The chemistry is published. The patents are public. The JSO specifications are available to any lubrication engineer on Earth. The reason it feels like a secret in other markets is not because the information is hidden. It is because there is no financial incentive to teach it. Every gallon of fuel you do not waste is a gallon that does not get sold. Every injector that does not need cleaning is a service that does not get invoiced. Every engine that reaches 400,000 kilometers without drama is a vehicle that does not need a premature rebuild. The Japanese discovered that the most expensive fuel secret is the one nobody tells you. Not a secret compound, not a black market additive, not a suppressed carburetor design from the 1970s. Just the correct oil, the correct fuel chemistry, and the correct interval, applied with the patience and discipline of people who never had the luxury of wasting fuel in the first place. That taxi in Osaka is still running. My contact sent me a message 6 months ago. It crossed 520,000 kilometers. The injectors have still never been replaced. If this changed the way you think about what goes into your fuel tank and your oil filler cap, hit like so more drivers see it. Subscribe if you want weekly breakdowns that give you real mechanical knowledge instead of expensive surprises. Drop in the comments the highest mileage engine you have ever driven, because the ceiling is much higher than most people believe. The fuel secret was never about the fuel. It was about understanding what happens to it after you pour it in.